Hello everyone. In this session, we will see what are the S parameter, what are the importance of S parameters, and the construction and working principle of vector network analyzer, spectrum analyzer, and signal analyzer. S parameters are the complex quantities which will give the information about reflection and transmission coefficients of a microwave network. For example, a two-port network will be having scattering matrix of dimension 2 cross 2. In that, first element is S11 which represents reflection coefficient. Second element is S12 which represents transmission coefficient from port 2 to port 1. Similarly, S21 represents the transmission coefficient from port 1 to port 2. Similarly, S22 represents reflection coefficient, that means amount of signal reflected at the port 2 itself. At low frequency, the characteristics of an electrical network can be described with the help of Z parameter, Y parameter, and ABCD parameter, whereas this kind of things are not possible at high frequencies because there is no ready-made devices available to measure the voltage and current at high frequencies. So in order to characterize the high frequency network, we need to find out the new type of parameter which will give the powers relationship between input and output ports of a high frequency network. Those parameters are called as S parameter, which gives the power relationship between input and output ports of a high frequency network. Now we will see the scattering parameters of two-port network in detail. S11 is the reflection coefficient, which is nothing but ratio of power reflected at the port 1 to the power incident at port 1 by keeping zero input at port 2. Similarly, S21 is the transmission coefficient, which is the ratio of power output available at port 2 to the incident power at port 1, keeping zero power at port 2. Similarly, S12 is the ratio of output available at port 1 to the power input at port 2, keeping zero input at port 1. S22 is the reflection coefficient, which is the ratio of power reflected at the port 2 to the power incident at port 2, keeping zero power at port 1. Spectrum analyzers are used to measure amplitudes of the complex signal. When you apply complex signal as an input for the spectrum analyzer, means it will show the amplitudes of various frequency signals independently. Second one is the vector network analyzer, which is used to measure amplitude and phase of the high frequency signals. Similarly, signal analyzer is the cross between spectrum analyzer as well as the network analyzer. Depending on our application, we can able to get the data from the signal analyzer. Now we will see the working principle of vector network analyzer. Vector network analyzer consists of microwave signal source, level adjuster, and a pair of splitter and directional coupler. One splitter and directional coupler is used at the transmitter side and another one is used at the receiver side. In between two directional couplers, a device under test is connected. Now the function of a microwave signal source is to generate microwave signal, that is also called as stimulus, which is applied to the splitter at the input side. The splitter will split the input signal into two parts. One is fed to receiver and detector. Another part of the signal is fed to directional coupler. The directional coupler will sample the signal. That sampled signal is sent to receiver and detector, and the main port of the directional coupler is connected to device under test. The output from the device under test is given to second directional coupler, and also the output of the second directional coupler is given to splitter. Splitter will split the signal into two equal parts. One is fed to the receiver or detector, another one is given to the level adjuster, and also the secondary port of the second directional coupler is connected to receiver and detector by finding the ratio of sampled signal at port 2. Similarly, sampled signal at port 1, we can able to find out the transmission coefficients of the device under test. In the vector network analyzer, the microwave signal from a sweep oscillator is divided into two components. One is test signal, another one is reference signal. The network or a component whose characteristics is to be measured is called as device under test. the test signal is transmitted through the device under test, while the reference signal passes through a phase equalizing length of a line. The device under test will alter the two important components of the reference signal. One is magnitude, another one is phase. The device under test will change the magnitude component due to its resistive in nature. It will alter the phase component due to its reactive elements. The function of spectrum analyzer is very similar to CRO. CRO will display amplitude of a signal as a frequency of time, whereas spectrum analyzer will display amplitude of the signal as a function of frequency. It is very much useful in analyzing the complex signals. Complex signal is one where it consists of multiple frequency components with different amplitude. When we apply complex signal through the CRO means it will display only one amplitude as a function of one complex frequency, whereas these signals are analyzed independently using spectrum analyzer. When a complex signal is applied to the spectrum analyzer, it will display the each and every amplitude as a independent frequency. In general, a spectrum analyzer can be able to measure received signal in frequency domain. In order to achieve the better resolution, the bandwidth of the intermediate frequency amplifier should be made as small as possible. In order to display all the frequency component without any missing, the shift speed should be as low as possible. In order to avoid the image frequency responses, the intermediate frequency should be chosen as high as possible. Spectrum analyzer can able to display exactly the frequency of a signal, stability against the time, spurious oscillation and interfering signal, noise, and distortion and effect of modulation of carrier. The signal analyzer is the modern version of spectrum analyzer. First of all, it will convert the RF input signal into intermediate frequency signal by mixing up the input signal with the local oscillator signal. Then it will convert intermediate frequency signal into digital signal. Then by using some of the DSP algorithms and fast Fourier transform, it will convert the time domain version of the signal into frequency domain version. Then it will display the amplitude as well as the phase of a signal as a function of frequency. The fundamental differences between network analyzer and spectrum analyzers are the spectrum analyzers are used to analyze the input signal, whereas a network analyzer creates a signal which is applied to the device under test. With the help of output signal from the device under test, a device is characterized. On the other hand, spectrum analyzer measures the parameters of a signal and not a device. They are commonly configured with the source. A traditional spectrum analyzers are used to measure amplitude only and produces a power spectrum measurement. A network analyzer converts the input signal into an intermediate frequency and measures both amplitude as well as the phase of the signal.